The problem that we are explaining is problem 62. The question is, what are the speed and altitude of a geostationary satellite orbiting Mars? Mars rotates on its axis once every 24.8 hours. The information that we need for this question is G, which is 6.67 times 10 to the negative 11 kilograms, which is the mass of Mars, which is 6.4 times 10 to the 23rd, and me, which is the mass of Earth, which is 6 times 10 to the 24th.
To solve this problem, you use the equation G times the mass of Mars times the mass of Earth over r squared equals mv squared over r. This simplifies to G times the mass of Mars over r equals v squared because the mass of Earth cancels out. This also simplifies to G times the mass of Mars over r equals v squared because there are multiple r's on each side of the equation. Then velocity can be substituted for 2 pi r over 89,280 and this comes out to be G times the mass of Mars over r equals 2 pi r over 89,280 squared. When the numbers are cross-multiplied, this comes out to be 4 pi squared times r cubed equals G times the mass of Mars times 89,280 squared. When the equation is rearranged to solve for r equals the cube root of G times the mass of Mars times 89,280 squared over 4 pi squared. Once the numbers are substituted in, r equals 2.0 times 10 to the 7th meters.
Once you find the radius, you use the radius of Mars, which is 3,390,000 meters, and place it into the altitude formula, which is r minus rm. The altitude will then be 2.0 times 10 to the 7th minus 3,390,000. The final altitude is 16,610,000 meters. From there, you can also find the velocity, which you use the equation 2 pi r over t. Now that we know r, we can put r into the equation next to 2 pi. So 2 pi times 2.0 times 10 to the 7th, with t being 89,280. From there, we can find the answer of 1,407.52 meters per second.